Welcome to the Temperate Deciduous forest of Hokkaido, Japan. One fun fact about this biome is that the trees in the forest regulate the carbon cycle, which regulates the surface of the earth. Therefore, this biome interacts with the geosphere. This biome is located in Hokkaido, Japan, and is a terrestrial biome. Its average temperature is 8 degrees Celsius yearly. Its annual precipitation is 1,150 milliliters a year. There are two types of soil in the Hokkaido forest, sandy and alpha soils. All the soils in Hokkaido are fertile. The Hokkaido forest is dominated by Mongolian oak trees and Mosul bamboo. Some animals in the Hokkaido include the Usuri brown bear, the Sika deer, the Eurasian red squirrel, the Siberian chipmunk, the Steller sea eagle, and the Sakhalin fox. The Mongolian oak trees provide shelter for the Siberian chipmunk. This benefits the chipmunks and doesn't really affect the tree. This is an example of communalism.
Based off the characteristics, density independent, many offsprings for better chance of survival, low energy investment in offsprings, small young Siberian chipmunk will be a case strategist.
There are a lot of plants in the deciduous forest of Hokkaido. A few plants in the forest are the Mongolian oak tree, the Japanese cedar tree, Mosul bamboo, carpet moss, evergreen trees, and Labium alberne plants. Based off the characteristics of a case strategist, density the Blankenstein fish owl is a species in the Hokkaido forest that is severely endangered. It is endangered for two reasons. One reason is the Blankenstein fish owl is endangered is because the forest is being cleared. Another reason is the construction of dams is taking away their habitats. The red-crowned crane, also known as the Japanese crane, is another endangered species. It is endangered due to its habitat being obliterated by human activity. Some red cranes are being caught and eaten or plucked for their unique feathers. The place where they lived was also turned into a rice field. In this simple food chain of the Hokkaido forest, the Usuri bear, an omnivore and predator, gets its energy from the Sika deer. The Sika deer is a primary consumer and gets its energy from the grass. The grass gets its energy from the sun. An example of predation is the Usuri bear being the predator of the Sika deer because it preys on the organism and eats it. The interaction between the grass and the Sika deer is herbivory because the deer eat the grass which is a producer. In this complex food web, the Mongolian trees and the Labium alberne plant gets their energy from the tree. The vole, red dragonfly, and the Sika deer gets their energy from the Mongolian trees and the Labium plants. The cougar and the Usuri bear gets their energy from the vole and the Sika deer. The decomposers are the nematodes and the earthworm, which eats the dead organism. The tree and the Labium plants are the producers. The primary consumers are the Sika deer, the vole, and the red dragonfly. The tertiary consumers are the cougar and the Usuri bear. The cougar is a generous species because it has a broad niche. It is at the top of its food chain and doesn't need a specific area. It can nest and eat almost anywhere in the temperate forest. The earthworm is a niche specialist in the ecosystem because it can only survive while burrowing underneath the earth and digging through the soil. The Usuri bear is the keystone species in the Hokkaido forest. The deciduous forest is very, very abundant when it comes to the Sika deer. And that species population grows rapidly. However, the Usuri bear helps regulate the Sika deer population. Without the Usuri bear, the population of the Sika deer will go up drastically and ultimately hurt and destroy the ecosystem because of overpopulation. Based off the characteristics of our strategies, which are density dependent, fewer offspring for better chance of survival, high energy investment in offspring, large young, and R-related species would be the Usuri brown bear.
The Usuri bear and berry-producing plants are a mutualistic relationship. The bear gains food while the berry plant seeds are transported to a new area.
Some of the Usuri bear population contracts lice and that is very parasitic. The lice sucks on the blood of the bear, benefiting from it while the bear is harmed. Two ecosystem service of the Hokkaido forest is that the Hokkaido forest maintains soil quality and the provisions of organic materials through the hydrological system. The forest also limits soil erosion and protects the soil from direct impact of rainfall. The trees of the Hokkaido forest provide a way to limit soil erosion and the rain goes to runoff. Economic benefits of the Hokkaido forest is the lumber industry. The vast amount of trees in the Hokkaido forest benefits the lumber industry well. It helps create processed wood, paper, rubber. These produce excuse me, fuel, medicines, and herbs. Agricultural industry. Grazing occurs in the forest and this creates areas for growing crops. Ultimately, this benefits the agricultural economy because it helps produce more crops, which can be put on for sale in the community. Excuse me. Human activity impacts the Hokkaido forest badly because the logging in the Hokkaido forest destroys habitats. Poaching is also another human activity that hurts the biodiversity of the forest because it drives many species to extinction. Poaching is illegal hunting, by the way. These human activities affect the way the biome interacts with the Earth's spheres. For example, logging affects the hydrosphere because there are less trees to provide transpiration. Another way that it affects the interaction is that logging takes away habitats which hurts biodiversity. This ultimately affects the forest interaction with the biosphere. Another interaction the biome has is with the atmosphere. Logging hurts that interaction because it releases harmful gas that hurts the atmosphere. There is plenty of nitrogen in the Hokkaido forest because of the vast trees. There are always trees dying and then decomposing in the soil, causing it to be rich in oxygen.
The nitrogen cycle. The end.